I know you want to talk about me, but just let us talk a little bit about orderings. So we discovered this table and trying to remember, again, for any relation, there are two operations, converse and complement. Right? And one of the, now jumping all the way, one we will see later, it would be terribly nice if you define one, you will get them all, but that would be a miracle. I actually...
Well, it would be trivial, but it would be a miracle in our current situation, in our current technological
age.
Yes.
I have to tell you this story. I know this. When I was doing STL, I mean, this is not tolerable, that you have to define less than and greater than separately, less or equal. So what I'll do, I'll just put in the standard namespace a bunch of templates which said if you do not have greater equal defined, just do not less than. Assume the existence of less than. And they held braggers. All the brilliant people from the standard, I mean, they're missing now, but all the brilliant people from the standard committee said, but what if I want to have a different meaning? What if I do not want greater than to be a converse of less than? That would be a fascistic restriction of his fundamental human rights. So they defeated it. They actually maintained that there are legitimate reasons for having less than, be less than, and greater than to do division with remainder. And there is indeed a reason, which I told you many times, called job security. Because if you rely upon such practices, nobody will ever be able to take your job away. Nobody will ever be able to maintain your code. So, but we will get to that practical issue soon. So when we talk about ordering, sort of the best thing is to concentrate on total ordering first. And total ordering is something which we sort of know. It's the ordering, say, of integers. Right? So what do we know? It's transitive. Then let us assume that we're talking about strict. Remember that, I chose strict as the default. Then we say we have strict. How do we write strict? We negate that. Yeah, we can. I wish I could. And then we need one more fundamental axiom. Sort of what is the meaning of total ordering? What do we imply by that? It means that things are linearized. Another term for it is linear ordering. Everything is either less or greater than everything else. So, in other words, we have an axiom known, and try to remember, I mean, names of axioms are good. You should, when you go to bed and when you wake up in the morning, brush your teeth, you have to say commutativity, distributivity, symmetry, reflexivity. You will eventually memorize them all. Try it now. Especially now braces are off, you could do it. So, naming things and good. So the third axiom is the axiom for total ordering called trichotomy. There are three things. Trichotomy. Rhymes with lobotomy. So trichotomy, and what does it mean? It's either A is less than B, or A is greater than B, or A is equal to B. and we will have to, not this very second, otherwise Param will strangle me, have a discussion what equality means. But let's assume, well, it's false, that you know what equality is. But simple things are very hard, the basic foundation. So, we have this trichotomy. By the way, I claim this trichotomy is exclusive trichotomy. And the exclusive, meaning not just one of these clauses is true, but only one of these clauses is true. And you, those of you, especially the brainy types, or those who believe themselves to be brainy types, should prove it. It's very simple. What could you use to prove it?
You assume that there are two, and you assume that it's
You have to use these axioms and see that if. Okay, I don't want to do that. Okay, so, and mathematicians pretty much are happy with these two things. The notion of partial ordering, which is pretty much just transitivity, and the example, and with total ordering. They know, I mean, these words, Nick said that some of them heard of weak ordering, but most of them actually don't quite know even what it means. It's not a common term in mathematics, but it is essential in computer science. Because very often, when we want to order things, we want to order them by something. By social security number, by name, by age, should be legal, but whatever. All kind of different ordering. You say, oh, they are partial ordering. No, in some sense, they are total ordering, in some sense. But in a sense of this one component of your object, individual, record, structure, right? And very many of our algorithms we want to use in the presence of such ordering. This is weak ordering. And what is weak ordering? It's ordering. Again, since we want strict, we need to choose which one, and choose strict. This. We need to do something with this. This no longer holds. Because if I order you by salary or by title, this no longer will be true. For example, we have Hernan is a manager, Ilya is a manager. So this is false, A and B are Ilya and Hernan. But they're not equal. I could clearly see, one has a black shirt and a mustache, another one, I don't know about mustache, has something, but not quite. So they're not equal, in spite of all that. So what do you do? And here comes this beautiful solution. You say that instead of equality, there is to be some equivalence relation, which a good way of thinking is an equality of some attribute. This is the attribute on which you are doing the ordering. So indeed, in this case, they are equivalent in terms of hierarchical title, both of them being fubas, important people. So, Puba.
So Fubar.
Fubar is something else. The Puba. Yes, Freudians. Yes. Now, I know everything about Coco and Nankipu, and all these names come from a great light opera by Gilbert and Sullivan called The Mikado. If you haven't seen it, you haven't lived. Ryan, what do you want? It is very funny. those of you who see it beyond words, requires that you know English, real English, beyond Hollywood movies, the next level. And for those of you who watch Mikado, you have to watch HMS Pinafore, which is another great production. There is a wonderful group right here at Stanford called Stanford Savoyards, which does every year the production of Gilbert and Sullivan. Affordable price of $15? I mean, even underpaid engineers could buy it. And there is a very good productions of Gilbert and Sullivan at both San Jose and San Francisco and Lampshade? What is it? No? Whatever. There are multiple productions, and you have to see them. What we're talking about computer science. Yes, weak ordering. So that's how you get weak ordering, right? And now, since I damaged all chances for Bram to teach you anything about programming, I'll shut up. No, I have to shut up.
Okay.
I told them that if you have these three axioms, such an ordering is called strict weak ordering. You replace this with, how do you write equivalence? Squiggly. This.
Something like this.
Something like this.
It's smaller.
Remember we talked about equivalence and three axioms of equivalence. What were three axioms of equivalence?
Transitivity, symmetry, and flexibility.
Very good. So anything, we know that basically people which fall in the same bin, two managers, are equivalent. Could be arbitrarily interchanged. They do it all the time. Well, natural language, man, let's send him to visual search.
So essentially you'd say that this relationship is a total ordering with respect to a particular equivalence relation?
It is like total. It isn't not total ordering. Total ordering says equality.
No, but you can say that if you define a key function, you can define a key function such that they are ordered based on
total ordering on the keys.
Yeah, so okay.
But
You get it, which is, you have equivalence relation, you have the ordering relation, and which is defined in terms of the other. Seems like
well, they typically are defined together. Literally, they sort of, you have to decide what you're talking about. You say, well, I care only about hierarchical positions, so I'll just look at management. All the managers are equivalent, and all the managers are greater than all the engineers, and all the VPs are greater than all the managers.
But the weak
And
ordering,
Jeff is, greater than anyone.
but the
You
weak
doubt
ordering
that?
implies
No,
an
but
equivalence relation.
another flavor would be to say ignoring case.
Or ignoring case. That's another equivalence relation, very common in programming. Because you don't have equal strings, you have equivalent string. Or all caps would look as all lowercase.
But in terms of your original question, the equivalence relation can be derived from the weak ordering, but not the other way around.
How could it be derived? Let's see how it could be derived. Right? Derive it.
Does
I give you
suggest-
R. Derive the corresponding equivalence relation.
it's RAB and RBA.
I don't think so. These are strict guys.
I mean, that would violate
Strictness. Yes, you have to compliment both. Compliments take you far, far away, especially with women. So one should not be saying things like that, especially one But you could keep it if they filed it. It's probably, I don't care.
If it's not ordered one way and it's not ordered the other way, then they must be equivalent. But given an equivalence relation, there can be many weak orders.
The easiest way of sort of seeing what you'd ask is our EQ, our equivalence relation of AB is equal, is defined as this. So if you give me R, I could get, usually there are other ways of doing it, which wouldn't require you to go through the pain of doing two comparisons both ways. But it works. And sometimes it is perfectly good code, by the way.
Right. Now that
So
we know
you
everything
guys
about
write all the code.
relations, now we should be able to write many.
We're not done with the specification.
Yes, we have a specification.
Can't.
But yeah,
Now you torture parameter.
what
When
specification
you
is
say some predicate defining a strict order ordering,
defining.
I would write it, okay guys, let me tell you. I would just say it like some strict weak ordering. Because you know strict weak ordering is right, I mean. And you could write it in a fancy way like that, or just in English, strict weak ordering. This is, no, this is fine. I didn't mean you to do that. This is just saying that one concept. No, just put it back where it was.
too late.
No,
Yes. No, I prefer this approach. I think it's better. Okay, so
And
given
then-
two
okay.
objects of the same type in some strict weak ordering, then what?
and
CMP.
Huh?
Name the
Yeah.
ordering.
CMP, R, SWO.
What's that?
Yeah, and
I want to say the smaller of A and B, but
No, you could say if comp A and B, return A, if comp B, A, return
let us
B,
write it this way.
and if
That-
neither, return A. Because you have to do it, you have
Okay.
to sort of do a toss
Just let
up.
us-
so
write it.
returns A if
If comp A, B, otherwise B if comp B, A, otherwise A.
okay.
So you think you need to do two compares to find the minimum?
Well,
I mean,
This is a
well, no,
specification.
that's
this is
the
not a-
logic, that's not the actual operation.
but at least logic, you need to describe logic, you need to write comp twice.
Well, you don't need to, you could just say, the equivalent to that is returns B if comp B A, otherwise A. But that sort of arranges it into the three possibilities.
Yes, but it will have only two lines.
Right.
Just an observation. And it possesses another remarkable property.
You can write it straight out of that.
Yes. So, I think our mathematical explanation of behavior should be made as close to code if it also makes it shorter. Because it's perfectly all right to write very different mathematics. For example, if I explain how square root works and say, well, I want to return, for x, I want to return y such as square of y is x. It's not a very constructive way of finding square root, but it's short and precise description.
Can you write the alternative?
Okay, so someone has to dictate it.
The alternative is just not the first line after returns. Just omit that.
Returns.
B, copy A,
copy A.
otherwise.
Okay.
Well, and then we might as well, guys, turn it into a C++ code, which requires a profound knowledge of things such as if requires parens, and return comes after if.
Now that he's given you hints, you can tell me what to type.
You're writing the full function?
No, just write. First start with this.
Okay.
Return copy A question mark B colon A.
Wow, he wants to be fancy.
You're the one who says to do things in the simplest way possible.
It also assumes make it so that even an old semi-retired guy could see it immediately. I could read this question mark stuff, but many people have difficulties.
Yeah, I guess you don't need to do that. Why not? Do we need an else?
John doesn't like it at all.
Oh, I just have a question. Well, the way we've specified this, A and B are objects, not values. So are we returning the objects or are we treating the values?
That's a question.
That's my question.
That's the question.
We haven't written the signature for this yet. Let's try to write the signature.
What's good about returning options?
You want to do something with it.
Ah, so if you copied, you couldn't get to the original. Plus, you did an unnecessary copy. Never copy if you don't need to. But here comes a difficult, terrible thing. Okay, let them write it. So how would you write it? Okay, he wants to write it. Okay.
So we have a
He's
type-
walking right into it. So let us.
We have the type of our.
You have people reporting to you present in the room.
We need to break that too.
Because you have this thing called comp. It has to have some type. I wouldn't say just, he will like it, I wouldn't like it. Because they say, I don't know what this compare is. So tell us what it is.
He was
You
writing. I'm
tell
not
us.
writing. I'm just.
You tell us how to do it.
It's a P.
We know what it is. You actually wrote it up there.
It's a string with ordering.
Yes, so say it is strict with ordering. And that's why we need to put it together and use camel case. And you say, but let us just before you do it. You see, this is actually what we want to say. Because this is, never mind what language we program in, that's what mathematically makes sense. And once upon a time in C++ 3012, there will be a way of saying it when they introduce constants. Right now, you cannot do it. Why you cannot do it? Because we haven't got constants, because they're dead. Or whatever, John will give you. Well, they have been stillborn. So what do? We cheat, and we say, why is it helpful? Well, it's helpful because we tell you precise semantics of what we require this thing to be. We tell that's what it has to be. Huh?
So we return a reference to P.
Okay.
Do that. We passing A and B as const refs.
That you can only return a const.
If you get const ref, what do you return? So you don't want cref now? Well, I mean,
And one of your reasons for returning references
I mean,
was
the
that
guy
you could do
behind
something.
you,
If it's const, there's nothing you can do.
Okay, so somebody
So you don't want to.
you don't want to make it const.
Well, this function is not messing with it.
No, let us write it. You're doing the right thing. Just good. This is good. So,
All right.
is it?
And we
Okay, we need to indent.
the predicate too.
Yeah, would be helpful.
Okay.
Yeah.
And closing brace. This is not Python.
We're not done.
We're not.
Now we're done.
No, we're not. Is it good, guys? It's actually, I told you, it's beautiful. It has many wonderful properties. Because see what he could do? He could give you two objects, and then, being a manager, he's going to give a raise to the smaller one, because he aspires to fence. Compare and give a raise to the smaller one. You could
Yeah, he's in favor of equalizing.
equalizing, yeah? Now, and he's a good guy. So, you could do this? 10,000, isn't that good, guys? Whomever underprivileged people, you still, you think? I think it's pretty good. I wish I could get it. I should work with you. But there is one unfortunate problem. What's the unfortunate problem? We also occasionally want to write min 3x. Do we want to write this? And then what happens? Well, compiler melts. We haven't reached computer melting. This does not compile. Why doesn't it compile? Because, oh, you want a reference. We could convert it to a const and give you a const reference, but you cannot really modify 3. So what do we do? And here comes the thing, which, again, sort of, it would be nice if we could write this thing. So let us think what we want to write. We really want to write something which would allow us, if we give it to non-const reference, return non-const reference. If we give it constant, non-const, it will return const, right? That would be good. We cannot do it. It just doesn't work. There is no single piece of code we could write which will do that. Okay?
In C++.
I mean in C++. I mean in Haskell, I'm sure. Or in your friend's language. No.
Rust.
Oh, Rust.
Rust. I'm sure in Rust you could write it in one line, will do everything, whatever. But it's still release 0.1. So there are some other problems.
0.9 now.
0.9?
Yes, but they're not 1.0. The semantic version.
Thought it was 0.1.
They're releasing all the time.
It was 0.11.
It was 1.1. Yeah, something. I'm not sure it's 0.11.
11.
Yeah, it's going to the one, the non-breaking version. It's getting there.
Yes, I'm not criticizing.
Yeah.
I'm just saying that we're talking about C++. I mean, nothing could be done in Java at all. I mean just beyond anything Java programmers could even imagine. But, you know, they're modern programmers. Their imagination is very, very limited. Right, Ilya? No comment, we say no comment. So he is our chief proponent of Java in the company. He and Inu. I used to work with Inu, and he always was saying, I wish we could switch to Java. I wish we could switch. Like every morning, we'll come to my office and start this whining. He spent his youth programming in Java.
He's programming in Fortran.
Okay, all right. Apparently he's past 30. So, in any case, we could solve this problem. Even the standard committee cannot. Show them how we could solve the problem. Yes. This copy-paste always works.
Powerful stuff.
Powerful stuff. So we overload on constant, and lo and behold, both version works. So in about 20 years, the standard committee will start putting this guy in. They still haven't figured out why it's useful. Huh? But in the meanwhile, that's what they give you. And why do they give it to you? Because they say that's how Alex wrote it. And they're right. So that's how I wrote it. I did not realize the importance of this. I didn't see how to solve it. I didn't think about overloading the constant. But even if I did, it would be a terribly uncomfortable thing. Because for every similar function, you would have two versions. And one of the things which we were going to learn is that like 99% of programming in C++ is writing the code which compiler could synthesize for you but doesn't out of spite. That is, you keep writing the same. This is good because you could use the technology which in another case, cut and paste. If it's identical, cut and paste this one. Here it wasn't quite identical. Here we needed to do some substitution. Very often, how do you know that your C++ code is really good? Because most of it you pasted from some standard place. Right? Why you have to do it, that's a mystery, but you know, that's how it is. Well, I'm not making it up.
No, we can actually try implementing greater than, and that would demonstrate.
We could try.
Things that were taken out of the study.
We need to look at greater than, of course. This is, he wants to rub my nose into that. Because this is, you know, how stupid could one be? I mean, one spends decades working on all these orderings and writing mean in the most generic way, and then he writes max, and he screws it up. And the person is me. And you'll say, well, but nobody will even remember that. Oh no, people will remember for centuries, because that's the max in the standard library. So for as long as C++ stand, my shame will be publicly visible, private members or not. Let us write max. Anybody wants to write max? Michael, I'm sure, is ready.
Well, I mean, you could do multiple things. You could say, well, max always returns what min doesn't. Or you could say, well, it just, I mean, I guess that's the best argument, is that if max returns one argument, then min returns the other. And so if you did that, you just have to do, I believe, do if compt A, B, wait, I have to think about it now. Yeah,
okay.
Oh, yeah, okay, there. But, you know, that favors the second item, whereas min favored the first item. And, you know, is that what you want? I don't know.
That's exactly what he wants. Not what he did.
I mean, is this an arbitrary choice? That's the question. If it's an arbitrary choice, then who cares? Well, it has to be consistent.
Again, let us just spend a little time thinking even about min. Of course, where is the problem? The problem does not arise when the one is less than the other. It's not, I mean, it's very clear what to return. Like if A is less than B, you better return A. If B is less than A, you better return B. Everybody agrees? That's the min. The third case, remember dichotomy. What if they're equivalent? What do we do for equivalent guys? Or does it matter?
It's something arbitrary but consistent. Return both.
Yeah! And in Lisp, you could even do it.
Throw an exception.
Throw an exception, yes. This is Pythonic solution, sure. Yes. Yeah, I mean, obviously, if two things are equivalent, that's just
Flip the coin.
flip the coin. Yeah. So the question is there some way we could just, before we even get to max, looking to min, what is the meaningful thing? If they're equivalent, which one to return, A or B?
So I said A because, you know, it's first and B is second and 1 is less than 2.
This is actually the correct argument. In a sense, what we want to preserve there is, as we will discover later on, there is this wonderful property of algorithms like that called stability. That is, if things are in the right order, keep the order. Right? Or in other way, but let's not go the other way. Let's not tell them that. Sort of. So it seems that.
So another way of saying the same thing is if you sorted a list and then or if you sorted two numbers and you said, okay, give me the min, you would expect that to be the first guy. Similarly, if you sorted them and you asked for the max, you would expect the second guy.
Or another way of putting it is that way. If they're already sorted, the first guy is min, the second guy is max, yes? It took me about 3 years after the standard was accepted to realize that for max. Which is that I did min correctly. And I figured out what the argument was, the stability. But then I thought that max is stable means exactly the same as min. That is, for equal things, I should return the first. Max should also be stable. But then this Param's remark no longer true. If things are sorted, you want min to be first, and you want max to be last, to be second. And we have to do that. So this is a tricky thing, which sort of took me forever. 3 years, that's pretty long. Ryan could type 11 million lines of code at that time. He types real fast. And here I worked on 2 lines. I did other stuff too, but it takes long. It takes long.
Another example to think about is, let's say you are writing a function to sort two numbers. I give you A and B, and you return. You give me, the two numbers sorted.
Let's write this one. replace that with void. Call it sort. You don't need to return it.
If B is less than A, then we swap. Now, let's say we had written this the other way around.
Not, would not. But if it's, some people could write this and swap A.
What this will lead to is, if they are equal, every time you call it, they'll be swapped, which is
And you want stability. You do not want equivalent elements to be moved if they are equivalent. And so the first implementation was correct. As we will observe eventually, guaranteeing that all your sorting-like functions are stable is extremely hard. Many of the best sorting algorithms are non-stable, cannot preserve the order of equal level. All right? So, I think you could write min today, which is not bad. What we will try to do next, and maybe I'll just not come, and that will allow me to talk. We need to see how to, we implemented very simple algorithm, and just once upon a time, I gave an interview, I forget to whom, it's published, and maybe either Dr. Dobbs or some Italian magazine, and I stated the following thing, that in order to have a good programming language should give me a facility to write correctly and efficiently three things. And you say, search engine, compiler. No, I didn't aspire to such great things. What I said was min, actually it was max. I said max, swap, and linear search. And I still claim this is true. And we're still, as we see, even like C++ allows you to get partially correct with min and max, but not quite. Because we still have to write two versions. We still have no ability to say what strict weak ordering is. We're cheating. We just use define, it's nothing. So we're not quite there. Or not. And what in some sense, before we study swap, we need to study a little bit how we write types. And these types which we will study are types on which you could do linear search. So for a while, keep these three algorithms in mind. But again, what is our goal is to write linear search, which is in the most general way. Our goal is to write swap in the most general way. And the same, and correct way. And we shall see, it's hard. Simple things are hard. And you say, well, but, I remember talking to somebody about a long time ago in this building, and the man is a great programmer, one of the greatest search engine programmer, and we were talking, he said, well, but I never need to swap two things. You cannot answer this. He claims that he never needs swap, he never needs max, or min, and he never needs linear search. Again, it's hard. people close their eyes, close their ears. They say that, no, we don't swap. I mean, he's a brilliant programmer, by the way. But apparently he doesn't need to do swap. So it's still a controversial thing that min, max, and swap and linear search are important. But I think they are. So we will talk about some very simple containers. And if I'm not here, then you might hear Param speaking finally. Bye-bye, guys.
Thank you.